All right, let's get started with our first neural network. I hope everyone can see my screen and this is visible. So let's get started with the first neural network. So what is a neuron? Basically, neural network consists of a neuron. Think of a neuron as a structure similar to something like this, which I'm gonna just show you in a while. So let me just draw a simple neuron which has basically a circle. This circle has a summation unit and has an activation unit. All right, so basically here we have several inputs. Inputs can be string, can be images, can be data or anything. So, and then we have something known as a bias, which is usually 1. Here we also have the weights associated with all the inputs. We usually initialize all the weight randomly at the beginning, but as we go ahead with the lecture, we are also gonna optimize our neural network. So we will learn how do I initialize my weight? Should I initialize it at randomly or should I initialize it uniformly? Does that make any sense while the calculating the accuracy? Yes, it does. We are going to learn all of that in detail. So first of all, I just need to explain you the very basic structure of a neuron. So I have something known as bias. Then I call this output as S, an activation function. What is an activation function? Basically, it activates when you give a certain inputs to it. So I'm gonna tell you about activation function in details in a while. So pretend the output is A. So after this, we need to calculate the loss, and then we need to propagate back because what happens, or let me give you an example. Let's say when my x is 2, my y should be 3. But when I feed in my x2, I got a value of 2. So what was my error? I missed by 1 units, right? Now I got my error. Now I need to uh, adjust my weights once again so that I get my answer close to 3. That's what we have to do. So that is nothing but back propagation. So we will see everything in detail. So let us just understand the basic structure of a neural network or a single neuron, how a neuron looks like. So we have some inputs, we have some weights, we have a bias, we have a sum unit, we have a activation function, we have a loss, then we propagate backwards. That's all a neural network or a simple neuron is. Just give me one sec. All right. So I hope you know now what is a neuron. So what is the equation of S? We are summing, right? So x1 w1 plus x2 w2 plus xn wn. Do you guys agree? But I forgot to mention the bias. So plus 1 times b. Am I right? Usually biases are usually initialized to 1. We usually initialize the bias to 1, and we usually initialize the weights uniformly, not randomly. So if you find videos on YouTube who are doing it randomly, that means they don't know the proper concept of a neural network. They have a superficial knowledge of a deep learning and machine learning. They don't know the math. So we are gonna see the math in detail. So let's build our simple neural network, which is something like this. So I have a task which my neural network needs to do. Okay, so I have x, I have y. So when my x is 0, y is 2. When my x is 1, y is 2.3. When my x is 2, y is 2.6. When my x is 3, it's 2.9. When it's 4, it is 3.2. When it is 5, it is 3.5. So I have these inputs, which is a very small set, which I'm gonna do. So whenever I feed in x as 0, the expected output is 2. So that is what I'm expecting right now. So I need my neural network to predict when I give x as 6, what would be y? I need to predict that. So if you observe this carefully, this is nothing but a line. If I say y is equal to mx plus c, you have slope, we have some slope, we have some constant, and we have the input. So we input is 0, 1, 2, 3, 4, 5, and this is the y, that is 2, 2.3, 2.6, 2.9, 3.2. That is what we have to do. So let's train, or let's create a first neuron. So in order to do that, first of all, we need to define some equations, and we need to define our neuron. How will it look like? So just give me a while. Let me just draw that. All right. So I'm gonna draw my very first neural network. All right. So has a summation unit, has the activation function, has one input x, the weight, then has a bias. So basically the bias would be 1. All right. Then we have the activation function, here would be s, then this output would be a. Then we calculate the loss, of course. Then we propagate backwards, or we adjust the weights. That's what we're going to do. So let me go a little bit detail in the math, because we, as I promised in my videos, this would be a complete, I would be teaching you complete math so that you understand the deep learning in detail. We don't want to have a superficial knowledge. If you know learning TensorFlow, Keras, and you can program it, but you don't know what's going on, that knowledge is not important because you just have a superficial knowledge. So let's learn that. So so first of all, we write the equation for sum, that is wx plus b, that is nothing but our sum. So after calculating the sum, we have the activation function. So pretend the activation function is a ReLU, or simply a linear activation function. So what are we going to do is, basically now we need to define the gradients, the weights, the biases, and stuff like that. So what I'm going to do is, step 1 is basically the partial derivative. So let's say this is L. So I need to calculate error with respect to D11. So that would be E with respect to A, that is, let's say this is the error. So E with respect to A with respect to S with respect to 1. That is the weight. That's how I get the weight, right? The gradient of the weight, that is the derivative of the weight. Now, if I want to get the gradient of bias, the way I do that would be, do you agree? So that's basically how I'm going to calculate the weights and biases. All right, after doing that, let us now try to calculate our first partial derivative. So I'm going to calculate my gradient E with respect to A. Now what is E? E is nothing but error, as I told you. So we gave a neural network, let's say 0, and we got output as 1. So we have some error, right? So we need to calculate the error. So the formula for error, we'll use a simple error right now, then later on we'll see cross entropy and other stuff. So my error would be, of course, my expected, that is y. What was I expecting was 2, but I got 1, right? So expected minus what I got, that is y minus a into y minus a, that will be an into 0.5. Now I'll tell you why am I doing 0.5. So basically our error is 0.5, or to be more precise for this example, why this, basically why half, because I need to compute the derivative of error, right? So now what is the derivative of error? So derivative of error with respect to a, so this is in form x raised to n, right? So dE by dA is equal to half into 2 y minus a into derivative of a is minus 1. So dE by dA is equal to minus of y minus a. Do you guys agree? Yes, you do. Of course. So now we need to calculate this part. So that is nothing but dA by dA dA by ds. So our activation function is nothing but a linear activation function. So derivative of x is 1. So this is nothing but 1, right? Or this, I'm sorry. Then I need to calculate s with respect to w. So what is my s? Wx plus b, right? So I have, if I differentiate with respect to w, I get as x, right? Do you guys agree? So what is my final gradient now? D with respect to dA, that is nothing but minus y minus a. dA with respect to ds, that is 1. ds with respect to dw1, which would be simply x. This is my equation number 1. Now similarly I need to calculate for dE with respect to the bias. dA with respect to dA, we already calculated it. Then this would be 1 because A with respect to S, we already did that, and S with respect to B. So this is my S with respect to B, so this will be 1, right? So this will be 1 as well. So I got my second equation. So I got my two equations which I need to program in Python. That is the gradient of W and the gradient of the bias equation. Now what would be my final so I got my gradients now. So whenever I go to the neural network, let's say my output was I was expecting 2 but I got 1, right? So the error was 1. So what I was expecting minus what I got, the whole square, I calculate the error. Now I need to compute, or I need to propagate backwards because I need to adjust the weight in order to get the output as 2, right? I need to adjust the weights and bias. That means I need to adjust this and this so that I get the output 2. Am I right? For just the purpose of example, I'm taking these numbers. All right, so let's do that. So the way I do that is, now I need to propagate backwards, or in simple I need to adjust the weights. So the equation would be W equals to, and the initial weight minus the learning rate into gradient of W, whatever we calculated here. Similarly bias, the gradient of bias. All right, that's it. That's a simple neuron which will predict the values for the equations. So let me show you a little bit in an organized way. I have already written it, so let me just go to my notes and I can show it to you. So this is a simple neural network that we are doing. So we have the inputs, that is the error. Error is nothing but y minus a the whole square. S is equal to wx plus b. Step 1, I apply the chain rule, derivative rule. Then I calculate the derivative for each of these. All right. Then that is nothing but these. I get the equation for the weight, that is the gradient weight, the gradient bias. Then I update the weights and the biases. That's all we need to do. Now let's look at the software code and see how we are gonna do that. So I hope this was clear. It was pretty basic. I was going pretty slow so that you understand. So let's go for the Python code now. I know this might be a little I would say it might be a little tough for you initially, but just refer my notes, refer the video, stop the video, try to understand the equations, and you should be fine. So let me see, where is my Python code now? All right, I think this is for the classification example. This is for the classification example. I can code this basically. Let me see if I have it here, linear regression. So yep, here is the code for it. So let me show you what I'm trying to do here. So initially what I'm doing is so one thing I want to say, we are gonna do coding like this, but in order to do coding like this we need to understand the basics. So that is why I am going very slow right now. So I'm initializing the weight as randomly, that is as 0.1 and 0.4. It can be anything. Epochs is number of times you want to train your network. Then for iteration in number of epochs, that is for I in number of epochs, I load in the data for data in next. So my data is 0, 1, 2, 3, 4, 5. Training input equals to data. So we know that. Then I need to calculate the new weight. So I say new weight equals to new weight. I supply in the training inputs, the W and the B. So this will go to a function known as new weights, which is here. It calculates the equation what we did. So S is equal to WX plus B. So I have just coded that. Then what is my Y? So what I was expecting, like if I pass in number 2, or let me zoom into my notes. So if I say 1, I should get 2.3, right? So if I give 1, I should get 2.3. Then I calculate the gradient, then I update the weight. So basically I'm updating the weights here. And similarly for the biases, I have just coded the equations here. And after that, I'm just running it for n number of times. So if I run this code, there should be a UI basically. So in order to show you how it works, so if I say train, so you see y equals to 0.3x plus 2. So it has came up with the weight and biases. So if I say if I say when x is 8, what would be the y? It will predict. So it says 4.39, and that's right. If you calculate the equations, this is just an example. I'm not teaching you coding right now. We will learn to code this. So where is my equation? So if I say 0.3x into 8, that is, not sure if I have a calculator here. So if I say 0.3 into 8, that's 2.4 plus 2, that's 4.4, and my neural network predicted 4.399. So that's right? So that's what a simple example on neural network is. Now